Nelson. I'm a professor with the School of Workforce Development at Conestoga College. I'm presenting a series of lectures on Industry 4.0. In this particular lecture, which will be presented in a two-part series, I'm going to cover the technologies that are involved in Industry 4.0. I've chosen this particular set of technologies, 9 of them, because they represent the pillars of Industry 4.0 that many analysts and engineers agree to be the basics or the basis of Industry 4.0. I'd also like to point out for students at Conestoga College, in particular the Process Quality Engineering program, that we follow the APA format for citations and references. And I've tried to follow that format in my slide deck here so that you have a good example of what we're expecting within the college for any presentation or paper that you may write. All right. So I'd like to start with the Internet of Things, sometimes referred to the Internet of Things and Services, so IoT or IoTS. This is one of the key enablers of Industry 4.0. The idea is that you're going to have a great deal of sources of information and a great deal of applications for that information. And the Internet of Things is kind of that idea of collecting sources and collecting information from a lot of different sources and pulling them together into a sort of a new industrial framework. Within the Internet of Things, these different sources are independent of each other. So they aren't necessarily coordinated. Information is generated at different times by different sources, completely independent of the other. Very often with this idea of Internet of Things, then each device or source of information has its own IP address. It can be active 24/7 and global. Let's take a really simple example. Here's something like a Google Home. So in this case, you have a person interfacing with a digital device, a Google device, which then connects to a modem within a home, which then may connect out to smart devices also within the same home, which then connect to any kind of a physical system, lights, radios, cameras, air conditioning, what have you. So one of the things that's part of this Internet of Things, maybe a different way of describing it, is this idea of a cyber-physical system. So you have some sort of a physical thing, it could be a person or a thing, connects to the internet, which then connects back out to some other internet-connected device. There's also this kind of three-way partnership that is implied with the Internet of Things, this man, machine, and product. So that's something to look for as we kind of continue describing different elements of Industry 4.0, that it's an Internet of Things, but also cyber-physical, or man, machine, and product. All right, a little more industrial example, something like a connected factory. So you might have incoming inspection that may be automated and an automated warehousing system, delivering product into an automated line with robots or other vision systems, what have you, different sensors on the product, packaging as it flows through. There may be automatic triggers out to resupply to tugger routes or tuggers supplying the factory. Production monitoring systems, quality systems, supply chain triggering, even HR, recognizing absence and shift and man-machine ratios and all the rest. So in a fully connected plant, you may have hundreds or even thousands of connections between different devices and systems and people, man, machine, and product, cyber-physical connections. All right, to take another example, maybe a little more personal for some people, is the idea of healthcare. So people can access services and can feed information into the service providers through all kinds of ways, everything from your cell phone um, to a watch with your heart rate monitored to maybe a digital weigh scale that's connected to the internet. So sort of all kinds of tracking systems if you have diabetes and so on. So all kinds of different ways that people can be connected to the internet through different devices, providing information. Healthcare providers also connected to information, or connected to the internet, gathering that information, using it to make decisions on behalf of their patients. Another idea, or one of the other pillars of Industry 4.0 is this idea of simulation. I see it as a low-cost development tool. So rather than making making physical prototypes, or physically rearranging machines or something like that on the shop floor, if you're trying to optimize flow, there are more and more excellent simulation tools that allow developers and testers to try out different things and in a digital world and see how they work. More and more now, industry is using simulation as a very serious tool to save money, improve processes, improve product, run demonstrations, provide training for employees and the like. All right, here's just an example, or a quick example of machining simulation.
So my name is Prasad Vaikar, and I am a software engineer in the simulation team at CNC Software. As a software engineer, I design and develop software features in the Mastercam simulator product, typically in Backlot and Verify. In Mastercam 2019, we have the toolpath analysis feature under the View tab. The toolpath analysis feature is available in all the 3 modes of Mastercam simulator. Toolpath analysis, as the name suggests, is used to analyze toolpath depending upon a color scheme. We can adopt a color scheme for different operations depending upon the segment length, the feed rate, and the tool used for these operations. The new and enhanced access controller panel is highly intuitive and resembles an actual CNC machine interface. It is primarily used for simulating movements of the machine axis, the spindle, and the turret. The access control feature enables the user to have a real-life simulation of the machine even before he starts cutting. This instills a confidence in the user, which is very critical to programming.
All right, so you can see just how powerful of a tool this is, and in my own experience in manufacturing, our tooling department really relied on this kind of simulation a lot to develop and optimize their tool programming, the paths and so on. It's very, very complicated parts we were manufacturing, so this could verify that the tool could reach into the different surfaces and features of the part. And then they used it also to develop new tooling, new approaches of brushing and deburring from internal surfaces, and to do some very, very complex machining that would have been very expensive to develop through trial and error, with a serious safety risk, in fact, where you could have tool breakage and some part damage, and within a machine or a machining center, that can be very serious, and you want to avoid that sort of a risk if at all possible. So it's very nice to be able to run in a simulated environment, and Mastercam is just one example of a tool that programmers, machinists, tool designers, and so on can all use together to ensure that the process is optimized. All right, here's a slightly more complex example, going from monitoring a tool path in a machine to monitoring a complete airport terminal. All right, so this is one of several different simulation software packages. It isn't the prettiest, but it's an effective demonstration of what different kinds of simulation software can do. So more and more software I'm seeing introduces the idea of people and operators within the model. I think it, it's very effective to address a lot of real world applications where we're not just talking about machines anymore, but a lot of interaction of how people move about the system and how lineups are formed and how the flow of the people interact with the system or defined by it. But you can see here, so this is everything from people through check-in, security, overall flow. You can see defining how many customs agents might be at a terminal, bottlenecks in the system, how they line up, how they move out to airplanes. You can see that sort of level of detail, the kind of clothing and things unpacked into bins and boxes. So the systems are very, very realistic. Coming through gates, loading zones, all the way out to the aircraft. You can develop things like this, which are like heat maps to show flow. If you've talked about spaghetti diagrams in a lean course, to appreciate how this can track flow. You can see there's data here, how many people are in queue, what the waiting times are. You can test different scenarios, how many different customs agents, what kind of lineups you might have, different times, how long it takes per agent to clear a person, decide how many conveyor belts you need. It can help, an entire organization like this decide staffing levels, flow, all the way back to designing airports if you want. And a massive amounts of data that gets generated. You can see, the graphs are generated, all sorts of real-time data. So someone who's developing or monitoring or configuring systems like this can test different scenarios, go back to the real world, take timing measurements, verify that their data is accurate, that their simulation is accurate, and then test out different models and different scenarios. This is beautiful stuff. And like I said, this is just one software package. I'll come back to my own slide deck in a second here and make a recommendation for you. That's just one example. From very small systems to very large complex systems. If you're interested in doing simulations like this, I would suggest as a starting place to try a product called Jamsim. I've put it on the slide deck here, Jaamsim. And Jamsim is an open source code, so it's been contributed by a lot of different people. It's free. It is not the slickest package, but as an entry-level exploration tool, it's fantastic. And I may, in a future video, give you a demonstration of what it looks like and a little bit of how to manipulate articles within the simulator. If you want to make it a little more complex, and in particular to introduce the idea of people, FlexSim is an excellent software tool. Okay, so moving on. One of the other pillars then of Industry 4.0 is this notion of big data. I've put the question here, is this information overload or information gold? So really it's both. If you look historically, the IBM Personal XT, so one of the first professional desktop computers that a person might use in their office, came with about 128K of RAM and a 10 meg hard drive. Now, I'm dating myself a little bit, but when I was a co-op student, going through my engineering degree, I worked for IBM, and the XT was reserved for the managers, and the IBM PC, which didn't even have a hard drive, was what everyone else received. And so you didn't even have 10 meg as a hard drive. You had a 360 kilobyte floppy disk drive. So all of your programs and software had to fit on one or two of these floppy drives. The entire operating system would fit on a 360K floppy drive. So it's rather remarkable now when you consider within a couple of decades, now something like an Apple Watch has 8 gigabytes of memory built into it, which is 62,500 times more than the original IBM XT, which presumably was used for more important things than the Apple Watch is today. So in fact, storage requirements have grown. We've gone from gigabytes to or kilobytes to megabytes to gigabytes to terabytes. My own PC, I have I don't know about 3 or 4 terabytes of storage, which I use as a photographer. So sorry, the yottabyte, which is 10 to the 24 bytes. I can't even imagine how much memory that is now. So here's the thing: the idea of the Internet of Things and these simulations, for example, they generate a great deal of data. And yeah, so like I found in a bit of a search here, vendors who maintain data warehouses. Now, this is a business by itself. Offer 6, 16, or even 256 petabytes. So 256 million gigabytes to a company if you need to store data. For me, that's an astounding amount of data. But when you think about what's being generated, here I just looked up for Tesla. So there's suggestions that Tesla has created or collected over 10 billion miles of customer vehicle autopilot data. So if you're a driver of a Tesla automobile, it is, as you drive around, constantly taking sensory input and not just using it on board to make some decisions, but it is collecting that data and sending it to the OEM, sending it to Tesla. There's a way of describing data with 4 V's. In fact, there's a 5th V that's been added. So velocity, how quickly is the data coming through? The volume of data, self-explanatory. The variety of data. So this is something with the expansion of Industry 4.0 and the expansion of the Internet of Things. The variety of data has exploded. It's coming from so many different sources now. It's remarkable. Those were the first 3: velocity, volume, and variety. So soon after, value was added to say, is it useful? You can have tons and tons of data that no one cares about and isn't adding any value. So this is something else now that has to be assessed when we're looking at big data. And I haven't put it in here, but the 5th V is veracity. In other words, is it good data? Can we rely on it? Is it accurate? Does it make sense? So that's becoming more and more important too. There's no point in looking at data that is high volume, high variety, and high value that's been fudged, or the sensors are no good. And in fact, with the process quality engineering program, which you're likely a part of if you're watching this video, the veracity of the data is probably what you might be concerned with if you're in a quality role. With that comes a challenge if you're a data analyst or a data scientist. I grew up in Excel. I used it for many, many years in analyzing a great deal of data. And when I was using Excel, I used to run out of record space. It wouldn't actually handle, I wouldn't be able to load my data files. I had too many records for Excel to manage. So Excel has increased the limit from just short of 300,000 records now to 1 million rows, but that is no longer enough. Minitab has an additional limit, or a slightly greater limit, of 10 million rows. But for a lot of applications now, that's no longer enough. So if you haven't exposed yourself to some big data, that might be hard to imagine. But if you think about larger companies connected to multiple devices, collecting data in real time, it's not hard to imagine that you're getting a whole lot more than 10 million records. In fact, you may find you get 10 million records of data every day or even every hour. So there's a lot of opportunities with big data, or challenges, if you will. However you want to look at this, it depends on your perspective, right? So with big data, there's about 7 different sort of stages or things that you have to do with it. There's this whole organizing and cleaning, or what I think of as scrubbing the data initially, then integrating data from different sources and making connections. Uh, then, because we're dealing with such massive amounts of data, and not all of it is useful, not all of it has high value, not all of it is accurate or has veracity, so there has to be a data reduction and compression phase. So now you've got a big chunk of data that's got variety and value and veracity and so on. So now you start doing something called feature analysis. To me, this is actually very similar to the data tagging in a Six Sigma project. You have y is a function of x, or your critical y that you're trying to solve or understand is a function of a number of critical x's. So you have to, and you may collect a bunch of data, and you have to tag it to understand what's coming from where, so you can develop the relationships. So instead of data tagging, the current terminology is a feature analysis, where you're trying to identify what the features are, or what are the useful features that make up this data stream. As a phase in here, before you start trusting the data and applying the data, because the visualization helps you recognize if it makes sense, to spot patterns that aren't otherwise obvious, to make some projections, to do a bit of reality check. If you then pass this through models and it gives you some conclusion, you want to do a little bit of a sanity check, make sure that it makes sense. So this data visualization can be very, very useful as an intermediate step. All right, so you've got good data and you understand it, and it makes sense. Now you can apply it, and one of the big things that I see big data being used for is process improvement. It isn't just information that you go, okay, that's nice, now I know. You need to do something with it to apply it. So I think process improvement is a huge step in this big data process. And finally, machine learning. The volume of data that comes through a system will overload a person. It's not possible anymore for humans to look at and interpret and comprehend the volume of data that's being generated today in the Internet of Things and with Industry 4.0. So there's an increasing reliance on this idea of machine learning, where computers are first taught to understand the data stream that's coming through. You do this feature analysis, you teach the computer to do this feature analysis, and then it starts making inferences and judgments based on the data and building data models. And this is a fascinating topic that some people may want to pursue. And in fact, if you're a process quality engineer or a student entering this field, you certainly have an opportunity to get a career in any one of these things, but I think in a process quality environment, I would suggest that these last three are the most critical, maybe where the rubber hits the road. So something to consider. In my opinion, then, as new process quality practitioners, whether this is a focus of your career or not, you must become comfortable working with and using big data. If you're not already comfortable in Excel, that's a great place to start. It helps you think in a structured way. So get comfortable with Excel. I would not stop with Excel until you've become comfortable with the idea of pivot tables. They're a great way of summarizing data and starting to see connections with your data. Certainly become comfortable with a program like Minitab or some other statistical analysis tool. Move into data visualization. You can do this still in Excel. It's a very, very powerful tool for developing graphics and the functionality that's been growing and growing, similarly with Minitab. But there are other programs which are specifically designed for bigger data sets and have some more intuitive visualization tools, something like Tableau. I mention it because it's available as a free package that students can use in a very full-featured way. And then explore machine learning. And again, there's a lot of free courses called micro courses, and I've chosen a set here. In fact, I'm going through these myself in Kaggle, which is a Google-sponsored system. And you can see you can take micro courses in Python, machine learning, and data visualization. And this is just the top of the list. It goes on and on. So I'll move to cloud computing. So it's more than just storage. The idea is with this massive amount of information, of course it needs a place to reside, but there needs some interpretation of that, and also it needs more computing power to work with that data. So companies like Microsoft, IBM, many others are providing cloud computing services, which include the software that companies may use, and they could be multiprocessing and distributed parallel processing. You can rent cloud servers. The idea is then that these networks, the software, and the storage are maintained by third parties. So if you're a company that's using big data, you don't necessarily have to invest in all the storage and the IT systems. So it lowers the cost for computing power, and you can focus on the use rather than the maintenance and upgrades and security of the data. All right, so I'm going to stop there. That's a big chunk to absorb so far. I've covered this collection of information so far, and so come on back to part 2 after you've had a bit of a stretch break, and I'll see you in the next video.